Hello. Welcome to another coding session. Today we are going to talk some more about the PS1 code from the last session. And today we are going to cover texturing, very basic texturing of a cube using the TIM file format. Yeah. So I think we will start, or I will start by showing my notes from the texture stuff I've been reading about. So let's see, switching here. Oh, I see a typo here instantly. Here we go. Another typo, primitives. Alright. So here are the notes from the last CD-ROM stuff. And kind of building on that, since textures needs to be stored on a CD, obviously. Or unless you're insane. We have texture primitives. So the PS1, if you go back, the PS1 has, let's see here. So it has a GPU for rasterizing pixels onto the screen. And in doing so, the PS1 provides a total of around, or exactly, 124 kilobytes of VRAM. And into that VRAM we can load textures. So just like a normal GPU, basically we load our textures, upload our texture to VRAM, which we can then map to the vertices of a polygon. A polygon being either a triangle or a quad. And yeah, you work with UV coordinates as normal. And let's see. So something unusual about the PS1 is that they have a concept called T-page and CLUT. So T-page stands for texture page. It's basically a number, I think. And CLUT stands for color lookup table, and that is also just an ID number. So diving deeper into texture page. Texture page is used to address the VRAM. So the VRAM is divided into grids. Each grid is then called a cell, I guess, and each cell is 64 by 256 pixels, and it's 16 bits per pixel. And this was done because of memory limitation. I guess memory bandwidth limitation. So you can't really, by subdividing the whole VRAM into sections, we can load just individual cells instead of loading like it's basically just a limitation on how much you can load at once. And the T page then is just an anchor point of where the texture is in the VRAM. So if we kind of draw here basic, so if you draw some lines here, this is the division, I guess, here, and something like this. So each like kind of cell here is a T page. 2, 3, 4. So you put your texture, for example, if we have a texture here, it's put into T page 1. And then the UV coordinates are local to that T page. So the UV coordinates will be 0, 0 up here, down to 64 by 256. And same here, if you had a texture here, this texture's UV would still be 0, 0 up here, and down 64 by 256 down here. Yeah, so very quick, that's how T-page works. And the CLUT, or the color lookup table, as far as I understand it, it's just exactly what it says. It's a color lookup table for the texture to use. So the colors of the texture are stored. And this, if we use 16 bits per pixel, we don't really need a CLUT because each pixel in the VRAM is represented by the is represented in full spectrum. But you can address the depth, have a color depth of 4 and 8. And in that case, if we have 4, for example, the color lookup table will be smaller and the color resolution will be smaller. And you could do this to save memory, I guess. Sorry. Yeah, so images on the PS1 when developing is stored as TIM files. And TIM files will then contain the T-page and the CLUT information for us. So it's kind of embedded into the file format. And then also add the actual texture data of the image, of course. Let's see here. Yeah. So this green code here. Let's see if it's fully visible. This is all the code you need for loading a texture from the CD to the VRAM. So very basic. First here, this part right here. We first have to, of course, read the actual bytes. So reading the bytes from the disk into the stack, I guess, or into the RAM. I think this will be. Yeah, of course, it's in the, because we don't know how large it is, so it will be stored in the RAM, in the heap data structure. And the PSYQ framework provides functions for taking the bytes and interpreting them as TIM file format. So you kind of, given the bytes for the texture, we do open TIM, given the bytes. And then you do read TIM, which will use the information from this line into the TIM data structure. And when you have the information stored, you can do load the image. And this will actually copy the I guess the data, the texture data from the CPU to the GPU or the VRAM. And this call right here, load image, is async. So to kind of wait and make sure we have it loaded, we do draw async here, which just waits, I guess, an entire GPU cycle. So just making sure that the operation for loading is complete. And we do the exact same thing here as we do up here, but here we do the T-page, or sorry, yeah, kind of the texture data, and here we do the color lookup table if there is a color lookup table, and that depends on what mode the TIM texture is in. So this can, as we said, this can be 16, it can be 8, or it can be 4 color depth. So depending on what we have here, the mode will be set to something. And if this bit is set, we have a color lookup table, so we load that into the VRAM. And that's basically it. And then down here is some code for saving 3 different variables that we need later on when we actually render. We need the mode, the prect, and the color lookup table rect. Yeah. So that's it for, like, I guess, overall theory. And in practice here, this is the code. Let's start up by showing how this actually looks in practice. So right now I have a texture map to a polygon cube using a flat shaded quad structure. Oh, sorry. We have to load the game build here and start simulation. Or I guess harder is it? No, is this correct? Yeah. So if we close this, here is a cube that has a TIM texture loaded just as I showed here. It's loaded from the CD, and then we use a couple of code calls to the GPU to make sure that we actually use this texture. And this is the result. So something very interesting to see here, if we go into configuration in the emulator and GPU, debug GPU VRAM here, and I think, yeah, you have a zoom in. So these are the frame buffer, both the front and the back buffer. And here, starting on up here, kind of, we have the actual texture for our brick. And so these are the different actual texture, and down here we have the color lookup table, which contains all the colors that you see here. For example, you can kind of see this blue, you can see this blue thing here. That blue little pixel is actually stored in the color lookup table. But I am not sure why this blue thing is showing up, because it's not in the original PNG. So maybe that's some compression artifacts when converting to the TIM format. Yeah, so this shows up here in the VRAM because we have done a call to load the image. So calling load image will put the thing into here, and when it's in the VRAM we can then later use it to texture anything that we draw. Yeah. So as I said, we save 3 different variables here. We save the UV coordinates for the texture, and then we save the UV coordinates for the color lookup table, and we also save the mode. So if we go down into the here, sorry. So before I used a poly, I think F4, or maybe G4, I don't know. G stands for garage shaded and F is for flat. So we changed that to be FT4 type, which is a flat textured quadrangle, a quad. And we used the exact same kind of drawing technique as before here. But now we can set the T page and the CLUT. And that I have explained. So there are some useful functions for getting the T page. There's a macro here, this thing, for converting. This converts the UV coordinates, the timprect, into an actual T page number. Same with the CLUT. It's just a macro that converts the color lookup table coordinates into a ID, so it identifies where in the VRAM we are. And also we set the UV coordinates. And this texture was 64 by 64 with an height. Yeah, and that's pretty much it for texturing. Something I wanted to do that we can kind of do live here is change up the load texture function. Because right now we kind of discard, as I said, we save these variables, which all come from the Tim here. But I kind of wanted to try to draw two different textures, or at least two different objects, and with potential for two different textures. So just to do that, we can create, if we do a struct, I'm not sure this cube is ever used anymore. Yeah, right? No, it's this is never used. We can delete this. We should only delete that. So type def struct, let's call this texture. I don't know, this I will probably delete later. So instead of the load texture setting this by hand, I think this can return a texture. And let's see. Here we can create the texture to return. And after we have 3 bytes, we can return, or actually we can just do this, right? And then we can create some more global variables. Let's move this up kind of out of the way. Let's move this up here. So here we all have our object. Let's create a texture. Let's call this brick texture. And then in our setup, where we kind of do the load texture, here we can do brick texture is equal to load texture bricks, and so this will not work anymore because we need to do brick texture dot tmode, and we need to do this for this and this and here and here. So let's see if this still works. Build script, which runs make and then runs the tool for creating the ISO. And we have the ISO, and let's see if we still have the brick texture. We do, I think. I mean, this looks like before, right? Yeah. Does it look lower res? No, I'm tripping. Now it looks good, but if I close, yeah, it looked weird before. Was it due to the scale? So now what I want to do and show is kind of how we created the brick texture. So let's see. Let's start by getting some texture. Let's see, 64 by 64 PNG texture maybe. I'm not sure if we have, I don't know how to do alpha blending yet. So let's do something simple. Let's do this lava. This is public domain, so we can use it. And so checking the size, it should be 64 by 64. Bit depth is 32. We shall see if this works. So let's drop this into assets for ease. So how I convert from PNG to TIM? It's not super trivial. There is a tool, an official dev tool, released by I don't know who, maybe Sony. It's a very old tool here. I got it from the course download, and this has a timtool.exe. Yeah, 22nd of October 1998, 1 year before I was born. Someone created this tool, which is very cool. So we can do import image files, and we go into our assets folder here. So here, as I showed earlier, we have the different cells. So if I kind of drag this up to there, there should also be a lookup table. I'm not sure. I'm not sure why there isn't a lookup there. It's there. It's totally there. There. So this is the lookup table here. So if you kind of drag this into this same cell. Actually, we can't use this cell because this cell will contain the brick texture. So we can, let's instead place it here in a totally different cell. Let's try to remember if there's anything else. Frame buffer should be, yeah, that's correct. So now if we do let's figure out how to kind of export this. Maybe add teams? No. Oh, it's created already. Okay. So it created lava f1.tim. I don't like the name, but that's fine. We can work with that, I guess. So, yeah, let's try this. So, that's how you create. Save. No, let's not save. So now we have this tim file, and we need to add it to the CD ISO file. And it's a data type, and we'll call this lava.tim. And it will come from lava f1.tim. So we get the tim file here, and then we can, let's start by checking if this actually works. So lava.tim, build, launch, open disk drive, boom. Yeah. So now we have instead this kind of lava thing. Yeah, and again it's super weird resolution. If I bring up this VRAM, now it's fixed. Weird. Anyway, now what I kind of want is, I want this cube, I want 2 cubes, kind of. So let's do another object called lava object, and texture called lava texture, and somewhere I think we do object here, set vector. So yeah, so we can kind of, let's do this as well. So this will take in an object pointer now. Oh, now I have to go through. Let's do mass change. So change all of this to be like that. So load model now takes in also an object. Let's do the same. So we load the same model. Actually, we can copy this, but we do lava object, and then this will be lava.theme, and this will be lava texture. So if what we can do here is kind of do the exact same thing. This is very much not, it's quite redundant. For now, this will not be permanent. And instead of do object, we do lava object. And instead of doing brick texture, we do lava texture. And up here where we set the position, we will do this, but for the lava cube. I'm not sure about the positions at all. Let's just do 100, let's see. 100 here, same scale. But this will of course be lava object. Yeah, so let's try this now. What is this called? PSYQ index, and it's not showing up in the search. Yes, maybe 100. Maybe 100 was a bit too much. But we can see here that the texture is loaded at least, and it looks good. Yeah, it looks alright, but I think the positioning was the positioning is probably off by a lot. Ugh, I'm not sure at all. So the camera position. Let's just do like 25 and see how that looks. Let's see if it shows up even. Game ISO, start emulation. Yeah, so it's not showing up. Oh wait, I think I know. I think I know why. Yeah. So we kind of have to do this again down here, but instead of object, we do lava object. This will be the same, this will be the same, yeah. Yeah. So now let's kind of change this back to be 100, 100. So we have to set the actual matrices for the other object as well after we have rendered the first object. Yeah, so it's showing up, but it's inside. Let's see. So 100 was perhaps a bit off. You know what? I'm thinking we can do something funny here. So 0. Let's do 0, 0, 0, and let's pull it down a bit. Let's pull it down by like minus 100. And let's scale up the X and Y by a factor of 4. And let's scale down this by a factor of 10. And let's see how this looks now. I did the scaling wrong, right? Yeah, no, the Y scale is supposed to be small, and the Z and X scale, and I think this was too small. Let's do 250. I want to create a lava floor, basically. Just messing around. Let's see if this works. Why is it? Oh, right. Okay. So the Y grows. It starts. Wait. Negative is up, and positive is down. So 250, and that was a bit over the cube. But if the cube is 0, 0, yeah, 200 maybe. Let's see. One last. Then we call this finished. For now. Game ISO. Yeah, that looks right. Cool. So we have so we're clipping. That's fine. So this is a pretty cool demo for textures, I think. So as you can kind of see, he goes through this in the course, but do you see the lava floor is kind of warping as we move? This is also happening on the brick, but it's harder to see. It gets much easier to see when the scale is bigger. The distance between the vertices are bigger, and this is because we don't. The PS1 GPU receives the screen space coordinates only. The GPU does not receive any kind of scaled Z value, and that makes it impossible to do perspective corrected projection for the textures. So the textures are not like projected correctly according to the perspective. And this concept is called an affine texture mapping. And this can be seen on older games on the PS1, but there are ways to get around this by subdividing. As I said, if there is a lot more vertices, the distance between the vertices are smaller, the effect gets less visible. So by subdividing things the camera is close to, so the closer the camera is to object, the more subdivision we do, the less effect of this kind of warping we will see. Yeah, and this is shown here in the video. So this is perspective corrected texture mapping. And here we see the exact same effect with the affine texture mapping. So that's kind of a cool side effect, I think, of old hardware. Yeah. So I think I'm happy here. Let's commit this code. And let's call this lava floor for texture demo. And what I want to do now is kind of branch off and call this texture demo. Yeah, because I think going forward in the course I am following in the lectures, we're going to build a semi-clone of Wipeout game. This game. I think it's not that big of a replication. We will only do like the tracks and the driving, and not really none of the UI or effects or kind of racing thing. We'll see if I do that on my own. But yeah, so we're kind of moving away from just messing around with random polygons and textures and loading, and moving into the final part of the course where we will create this kind of clone game. So I think the next session I do with the PlayStation 1, it will be a bit into this project, maybe even when it's finished. And I can show you kind of how this sort of project looks in C on the PS1. Yeah. Very cool, very exciting, very fun. Yeah, hopefully this was kind of interesting. I kind of rambled through textures and all the sort of stuff. So feel free to point out if I missed anything, or if you have kind of questions. I would love to discuss or try to answer any thoughts you have on this whole thing regarding textures and loading into VRAM and stuff. Yeah, so thank you very much for watching and have a good day. Bye bye.